A bombshell just dropped on the astronomical community, but it wasn't from space. While the West's most powerful telescopes were blind, Chinese observatories released crystal-clear images of the interstellar Comet 3, I-Atlas. This isn't just about a new comet, it's about a seismic shift in who controls our view of the cosmos. This sudden pivot in the observational balance is stirring more than scientific curiosity. It may signal a new era in how we monitor these alien visitors. Let's explore this together.
Strange composition.
So, what makes this visitor from another star so bizarre? Interstellar objects are messengers from distant star systems, and 3I Atlas is only the third one we've ever confirmed. Unlike its predecessors, Oumuamua and 2I Borisov, this comet is giving us an unprecedented look at the chemistry of another solar system. Early observations from teams led by astronomers like Quanji Ye, using instruments like the James Webb Space Telescope's NIR SPEC, have revealed an unusual chemical fingerprint. The cloud of gas and dust surrounding it, called a coma, is incredibly rich in carbon dioxide, with some studies suggesting the CO2 to water ratio is more than 10 times higher than that of typical comets from our own solar system's Oort cloud, like Comet Hale-Bopp. This suggests it formed in a very different and likely much colder environment, possibly in the outer reaches of a red dwarf star system. With a nucleus estimated to be between 2 and 5 kilometers in diameter, and a hyperbolic trajectory with an eccentricity greater than 3. It's a pristine sample of the building blocks from a completely alien planetary system, delivered right to our doorstep. Every piece of data is a clue to how planets and life might form elsewhere in the galaxy, which is why every single observation is so critical.
Telescopes go dark.
But what happens when our best eyes on the sky suddenly close right as this once-in-a-lifetime visitor is putting on its best show? This isn't a hypothetical fear, it's the reality that just unfolded. Major observatories like the Hubble Space Telescope, the JWST, and the European Southern Observatory's Very Large Telescope are the workhorses of modern astronomy. They provided the critical data that shaped our initial understanding of 3I Atlas. But these are incredibly complex machines. In mid-2024, Hubble had to switch to a single gyro mode, a necessary fix that nonetheless impacts its efficiency and scheduling flexibility. The VLT's 4 main telescopes periodically go offline for the recoding of their massive 8.2-meter primary mirrors, a delicate process that can take a telescope out of commission for weeks at a time. Even the JWST has faced challenges with its instruments. The transcript suggests several of these key Western telescopes went offline just as the comet's activity was evolving, creating a critical data gap. This isn't just bad luck. It exposes a systemic vulnerability in a highly centralized system, a single point of failure that can blind us at the worst possible moment.
China steps in.
But the sky is never truly silent. Someone else was listening. Into this observational vacuum, China's astronomical community stepped forward, leveraging their growing network of advanced facilities, such as the 2.16-meter telescope at Xinglong Station, part of the National Astronomical Observatories of China. They released sharp, high-resolution images of 3I Atlas. These aren't just blurry snapshots, they are deep-field images that capture the comet's evolving structure with stunning clarity. Established in 2001, the NAOC has rapidly developed world-class capabilities, driven by a national strategy to become a leader in astrophysics. Scientists like Jing Li and her colleagues are at the forefront of this effort, utilizing these modern facilities to monitor transient astronomical events. By capturing fresh frames of the comet's coma when other major facilities were dark, Chinese astronomers didn't just fill a gap. They seized a moment of scientific leadership. The timing was impeccable, demonstrating that years of heavy investment outlined in their 5-year plans have paid off, positioning them to make critical contributions right when they matter most.
Data controls narrative.
Here's what really matters. In science, the person with the data writes the first draft of history. By capturing and publishing the first high-quality images of 3I Atlas during this critical window, Chinese teams will inevitably shape the scientific narrative. These initial observations become the reference points for all subsequent research. Think back to 1995, when Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b. Their data, showing a massive planet orbiting its star in just over 4 days, created the hot Jupiter category, and honestly, dominated exoplanet theories for years. Similarly, the Chinese images might be the first to identify key features in 3I Atlas, setting the agenda for the entire global community. Their interpretations, published rapidly on preprint servers like Archive, will gain significant mindshare before the formal peer review process is even complete. In a scientific ecosystem, where reputation and early access are paramount, this gives Chinese teams a powerful boost, allowing them to take the lead on developing the first credible models of this alien object's behavior and origins.
Data sovereignty.
This isn't just about science, it's about control. For decades, Western astronomy has largely operated under a philosophy of open data, with archives like NASA's MAST providing public access. But that's not the only model. For example, data from the European Southern Observatory often has a one-year proprietary period for the observing team before it becomes public. As different nations become major players, the question of data access becomes more complex. The decision to release or withhold data can become a powerful tool of soft power. If China's new images and follow-up data are shared openly, it could foster a new era of global collaboration. However, if access is controlled through institutional channels, it could complicate independent verification and, honestly, sideline researchers from other countries who lack the right connections. This situation brings up serious questions about scientific sovereignty and the norms of data sharing. Who owns data from the cosmos? How that question gets answered will determine whether the future of astronomy is more collaborative or more fragmented and competitive.
National prestige.
Let's be clear, observing the cosmos is about discovery, but it's also about power. Space science is deeply intertwined with national pride and global influence. China has long used its space program to showcase its technological prowess. The Chang'e 5 mission in 2020 returned 1,731 grams of lunar material to Earth, the first sample return in over 44 years, a massive prestige victory. Releasing key images of a rare interstellar wanderer like 3I Atlas, especially when others cannot, is an equivalent statement in deep space science. The media narrative practically writes itself. China steps up when others falter. This resonates far beyond academic circles, bolstering national prestige and justifying massive government budgets for science and technology, creating a self-reinforcing cycle of investment and achievement. It reframes the 21st century space race as a contest not just of exploration, but of knowledge generation, positioning China as a leader in a frontier domain previously dominated by the West.
Infrastructure fragility.
What does it say when the world's most powerful eyes can all blink at once? This episode serves as a stark reminder of the fragility of our global astronomy infrastructure. The catastrophic 2020 collapse of the 305-meter Arecibo Observatory is a perfect example of how the loss of a single, unique facility can leave a massive gap in our scientific capabilities for years. For decades, the community has relied heavily on a handful of flagship observatories. While these telescopes are incredibly powerful, this centralization creates a single point of failure. Funding cycles, maintenance, or technical issues can take multiple key instruments offline simultaneously. The 3I Atlas event proves this model is unsustainable for time-sensitive science. It highlights an urgent need for a more diversified and distributed global network, something the upcoming Vera C. Rubin Observatory in Chile will help address with its continuous sky survey. Relying on a few titans is a risky bet when the universe doesn't wait for our schedules, and a single nation with agile facilities can now step in and dominate a major discovery.
Verification questions.
New data is thrilling, but it arrives with a critical question: can we trust it completely? The scientific process is built on verification, and integrating the Chinese data on 3I Atlas isn't simple. Are the new images calibrated in a way that is fully compatible with previous data? To answer that, the global community needs the raw FITS files and all associated calibration frames, the darks, biases, and flat fields required to remove instrument signatures. Without these, it's impossible to perform accurate photometry, the measurement of the comet's brightness, to see how its activity is changing over time. Furthermore, high-precision astrometry, or the exact measurement of the comet's position against background stars, referenced by the Gaia catalog, is crucial. This data is needed to refine 3I Atlas's hyperbolic orbit and search for tiny non-gravitational forces caused by outgassing. Full transparency, including sharing data reduction pipelines, is the only way for the results to be independently replicated and universally accepted by the scientific community.
What the images reveal.
So, what are the Chinese observatories actually seeing in these new frames? The released images are more than just pretty pictures. They are rich with scientific data that allow for precise physical modeling. Observers are pointing to subtle but significant details, like hints of new jets of gas and dust erupting from the comet's nucleus. These jets are crucial because they produce non-gravitational forces. They act like tiny rocket thrusters that can subtly alter the comet's path by hundreds of kilometers. Tracking these minute deviations, a specialty of astronomers like Marco Micheli, requires high-cadence astrometry from images like these. Furthermore, brightness gradients across the coma seem to be shifting, which could suggest that the outgassing is anisotropic, happening from specific active patches on the surface. By taking many images in quick succession, the Chinese teams can monitor rapid, transient events that might otherwise be missed. This morphological data provides the crucial visual context needed to interpret spectral data from other observatories, past and future, becoming the scaffold upon which a complete understanding of 3I Atlas will be built.
Global wake-up call.
Bottom line, this event is a shock to the system of global astronomy. It's a wake-up call on multiple fronts. First, it forces a reckoning with the fragility of our observational infrastructure. It will likely accelerate pushes for more distributed networks and formalize coordination through frameworks similar to the International Asteroid Warning Network. Major observatories will likely re-evaluate how target of opportunity time is allocated to ensure that high-priority interstellar objects get immediate, coordinated follow-up. Second, it recalibrates the geopolitical landscape of space science, forcing Western institutions to forge new alliances and advocate for more resilient, internationally managed observatories. Finally, it shines a light on the changing nature of discovery itself. It's becoming less about a lone genius at an eyepiece and more about managing vast, complex, and sometimes fragile global systems of technology, data, and collaboration. The 3I Atlas event is a powerful case study in this new scientific reality. The story of 3I Atlas is a powerful reminder that the universe doesn't wait for anyone. A visitor from another star system is hurtling through our cosmic backyard, and for a critical moment, China's observatories were our only eyes. This event will reshape not just our understanding of this comet, but the future of how humanity watches the skies. What are your thoughts on this shift in the cosmos? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of technology and space. Thank you for watching Stellar Tech. Have you ever wondered what secrets lie beyond our solar system? Bill Nye recently revealed something that honestly sent shockwaves through the scientific community. Voyager 1 has detected 300 massive objects floating in the depths of interstellar space. After 45 years of exploration, this aging spacecraft continues to make discoveries that challenge everything we thought we knew about the cosmos. These aren't just random space debris. They're mysterious structures that could hold the key to understanding whether we're truly alone in the universe. Today, we're diving deep into Voyager's most mind-bending revelations. The genesis of Voyager's epic journey. Back in 1977, NASA launched what would become humanity's most ambitious space exploration mission. Voyager 1 and Voyager 2 were originally designed for a simple 5-year mission to study Jupiter and Saturn. But these remarkable spacecraft had other plans. The timing was perfect, a rare planetary alignment that occurs only once every 175 years, allowed the probes to use gravitational slingshots to reach the outer planets faster than ever before. What started as a modest exploration of gas giants evolved into the grand tour of our solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, capturing images that, well, totally revolutionized our understanding of these distant worlds. The mission's success exceeded all expectations, with both spacecraft continuing to function decades beyond their planned lifespan. The secret to their longevity lies in their nuclear-powered systems and robust 1970s engineering. While their computers have less processing power than a modern calculator, their reliability has proven unmatched. Today, nearly half a century later, these cosmic pioneers continue transmitting data from the edge of known space, redefining what's possible in space exploration. Breaking the ultimate barrier. August 25, 2012 marked a historic moment in human exploration. Voyager 1 became the first human-made object to enter interstellar space. At 11 billion miles from the Sun, it crossed the heliopause, the boundary where our Sun's influence ends and the vast wilderness between stars begins. 6 years later, Voyager 2 joined its twin in this cosmic frontier, making them humanity's only ambassadors to interstellar space. The journey to this milestone wasn't easy. As the spacecraft approached the heliopause, they encountered a turbulent region where the solar wind collides with the interstellar medium. This cosmic battleground creates a protective bubble around our solar system, shielding us from the galaxy's harsh radiation. Voyager's instruments revealed that cosmic rays beyond this shield are 3 times more intense than within our solar system's protective embrace. The transition into interstellar space wasn't gradual, it was like stepping from a bustling city into a silent wilderness. The spacecraft's magnetometers detected the sudden change in magnetic field direction, while particle detectors registered the dramatic shift in cosmic ray intensity. This moment represented humanity's first direct contact with the space between stars, opening an entirely new chapter in our cosmic exploration. The mysterious humming of deep space. One of Voyager 1's most intriguing discoveries came in the form of sound, a low, persistent humming detected in the vast emptiness of interstellar space. This cosmic symphony isn't actually sound as we know it, but rather vibrations in the sparse gas that exists between stars. The discovery challenged our understanding of interstellar space as a perfect vacuum, revealing instead a dynamic environment filled with subtle activity. The humming represents the vibrations of electrons in the interstellar plasma, creating what scientists call plasma waves. These waves provide crucial information about the density and temperature of the interstellar medium, helping us understand the conditions that exist in the 99.9% of space that lies between star systems. The consistency of this humming suggests that interstellar space has a more uniform structure than previously thought. NASA's Nicola Fox emphasized the significance of this discovery, noting that no other spacecraft could have made such observations. The detection required Voyager's unique position beyond the heliopause and its sensitive instruments, which continue to function despite the extreme cold and radiation of deep space. This cosmic humming serves as a constant reminder that even in the apparent emptiness of space, there's always something happening. We just need the right tools to detect it. Defying death in the cosmic deep. Voyager's survival story honestly reads like science fiction. These spacecraft were designed to operate for just 5 years, powered by plutonium-238 that, gradually decays over time. As the radioactive fuel ages, it produces less heat, forcing NASA to make increasingly difficult decisions about which systems to shut down. Heaters that were meant to keep instruments warm in the -270 Fahrenheit environment of space, well, those were turned off years ago. Yet somehow, all 5 scientific instruments on both spacecraft are still functioning perfectly. This really defies all engineering expectations and, frankly, puzzles NASA experts who expected the instruments to freeze and fail long ago. The spacecraft's resilience truly demonstrates the exceptional quality of 1970s engineering and the conservative design philosophy that built redundancy into every system. The power situation gets more critical each year, with both spacecraft losing about 4 watts of power annually. NASA engineers are constantly juggling which systems to keep online, always prioritizing the most scientifically valuable instruments. Despite all these challenges, the spacecraft continued to transmit data across the 15 billion-mile void, with signals taking over 22 hours to reach Earth. This remarkable endurance has extended humanity's reach into the cosmos far beyond anyone's wildest dreams. The shape-shifting boundary of our solar system. The heliopause, which is our solar system's boundary, isn't the static barrier scientists once believed it to be. Instead, it's this dynamic, ever-changing frontier that actually moves and shifts like a living organism. Data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite reveal that this cosmic boundary creates unexpected angles and irregularities, really challenging our understanding of how solar systems interact with interstellar space. This discovery helps explain why Voyager 1 and Voyager 2 entered interstellar space 6 years apart, even though they were launched just weeks apart. The heliopause had shifted significantly between their crossings, demonstrating the dynamic nature of this cosmic frontier. Scientists observed the boundary moving at speeds that just contradicted existing models, suggesting that the interaction between solar wind and the interstellar medium is way more complex than previously thought. The implications are, honestly, pretty profound. If our solar system's boundary is constantly shifting, it affects how cosmic rays penetrate our protective bubble and influences the space environment around all the planets. Recent studies published in Nature Astronomy describe these findings as eye-opening, acknowledging that they challenge some fundamental assumptions about heliospheric physics. Future missions, including NASA's upcoming Interstellar Mapping and Acceleration Probe, will help scientists better understand this mysterious boundary.
Electronic aphasia in deep space.
In May 2023, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude control system started sending garbled, incoherent data back to Earth. Like a person struggling to speak clearly, Voyager 1 seemed to lose its ability to communicate effectively, sending random patterns instead of meaningful telemetry about its health and status. The mystery only deepened when engineers realized that, despite the communication problems, Voyager 1 was actually functioning perfectly. Its radio signal remained strong and stable, which meant the high-gain antenna was still properly pointed toward Earth. The spacecraft's scientific instruments continued operating normally, completely unaware of the communication anomaly affecting their host vehicle. NASA's investigation revealed that the attitude control system had switched to a backup computer that had been dormant for years. A simple command to switch back to the primary computer resolved the issue, but the root cause still remained puzzling. Engineers suspect that cosmic radiation or maybe an errant command from another onboard system triggered the switch, highlighting the challenges of operating decades-old technology in the harsh environment of interstellar space. This incident demonstrated both Voyager's vulnerability and its remarkable resilience, proving that even after 45 years these spacecraft can overcome unexpected challenges.
Cosmic IT support across 15 billion miles.
Managing Voyager's computer systems presents some pretty unique challenges, honestly, challenges that make Earthbound IT support look, well, simple by comparison. These spacecraft operate with technology from the 1970s, including computers that have just 70 kilobytes of memory. That's actually less than a single smartphone photo. Yet NASA engineers regularly send software updates across the 15 billion mile void, and, that process takes over 22 hours each way at the speed of light. The programming challenges here are immense. Engineers have to write code in assembly language, the most basic form of computer programming, because get this, the spacecraft don't have operating systems or any advanced programming tools. Every instruction has to be crafted to work directly with the hardware, which really requires intimate knowledge of systems that were designed nearly half a century ago. And the code, well, it has to be absolutely perfect. There's just no opportunity for quick fixes when the nearest technician is 15 billion miles away. These software updates aren't just, routine maintenance, they're actually lifesavers. Over the years, updates have fixed failing hardware components, optimized power consumption, and even activated backup systems when primary components failed. One critical update actually saved Voyager 1 from potential disaster by activating a fail-safe mechanism when a hardware component stopped working. This kind of cosmic IT support honestly represents one of the most challenging technical achievements in human history. And it's what's kept humanity's most distant explorers operational against all odds.
Revolutionizing our understanding of planetary worlds.
Voyager's planetary discoveries, fundamentally changed our understanding of the solar system. Jupiter revealed itself as a world of extremes, with hundreds of massive storms, glowing auroras at its poles, and a complex ring system that's even more intricate than Saturn's. The Great Red Spot, which is a hurricane larger than Earth, had been raging for centuries, really showing us the incredible power of atmospheric dynamics on gas giant planets. Saturn's rings, once thought to be simple bands of ice and rock, turned out to be incredibly complex structures with thousands of individual ringlets and honestly, these braided patterns that just defied explanation. The discovery of spokes in Saturn's rings, those mysterious dark features that rotate with the planet, revealed that ring systems are way more dynamic than anyone ever imagined. But maybe the most shocking thing was the discovery of active volcanoes beyond Earth. Io, Jupiter's innermost large moon, displayed sulfur volcanoes erupting hundreds of miles into space, while Neptune's moon Triton showed nitrogen geysers erupting at temperatures near absolute zero. These discoveries proved that geological activity wasn't just limited to rocky planets, opening up new possibilities for understanding planetary formation and evolution. And most intriguingly, Voyager revealed that Europa and Enceladus likely harbor vast oceans beneath their icy surfaces, making them prime candidates for harboring extraterrestrial life. The Golden Record and humanity's cosmic message. Each Voyager spacecraft carries humanity's most ambitious message to the cosmos, the Golden Record. This 12-inch gold-plated copper disc contains sounds, images, and music representing Earth's diversity, including greetings in 55 languages and natural sounds from wind, rain, and animal calls. The record serves as a time capsule of human civilization, designed to survive for billions of years in the vacuum of space. Carl Sagan, who really spearheaded the Golden Record project, envisioned it as humanity's introduction to any extraterrestrial intelligence that might encounter the spacecraft. The record includes mathematical and scientific information, human anatomy diagrams, and cultural achievements ranging from Bach to Chuck Berry. It represents our species' optimistic belief that intelligence and curiosity are universal traits that could bridge the gap between civilizations. The Golden Record transforms Voyager from mere scientific instruments into cultural ambassadors. Long after their scientific missions end, these spacecraft will continue carrying humanity's message through the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star, Gliese 445, potentially becoming the first human artifact to enter another star system. This cosmic message represents humanity's profound desire to connect with something greater than ourselves, embodying our species' eternal quest to understand our place in the universe.
Legacy of discovery and future exploration.
Voyager's legacy extends far beyond its original mission, inspiring decades of subsequent space exploration. The spacecraft's discoveries at Jupiter led directly to the Galileo and Juno missions, while Saturn observations inspired the Cassini-Huygens mission that spent 13 years studying the ringed planet. Voyager 2's brief encounters with Uranus and Neptune remain our only close-up studies of these ice giants, though, future missions are planned for the 2040s. Today, both Voyagers continue transmitting data from interstellar space, with NASA expecting to maintain contact until the late 2020s. The spacecraft will eventually fall silent as their power sources decay, but their journey will continue for millions of years. In about 300 years they'll enter the Oort cloud, and after 30,000 years, they'll leave our solar system entirely to orbit the galactic center. Current missions like Europa Clipper and the planned Dragonfly mission to Titan build directly on Voyager's discoveries, targeting the most promising locations for finding extraterrestrial life. The spacecraft's detection of subsurface oceans on Europa and Enceladus has absolutely revolutionized astrobiology, making these moons priority targets for future exploration. Voyager's story reminds us that the greatest discoveries often come from pushing beyond our intended limits, proving that human curiosity and engineering excellence can overcome any obstacle the universe presents. From detecting mysterious objects in interstellar space to revealing the hidden oceans of distant moons, Voyager 1 has fundamentally changed our understanding of the cosmos. Bill Nye's revelation about those 300 massive objects reminds us that even after 45 years, these remarkable spacecraft continue making discoveries that challenge our assumptions about the universe. As Voyager drifts ever deeper into the cosmic unknown, it carries with it humanity's greatest hopes and dreams. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible journeys into the mysteries of space and science. A rare visitor from deep space is flying through our solar system. The object, now officially named 3Y Atlas, has astronomers spotting another mysterious interstellar visitor racing through space. NASA's recent data has revealed anomalous features that have sparked intense debate over its true nature. Some scientists fear the possibilities this mysterious visitor presents, suggesting it could be more than a mere comet or asteroid, perhaps even a disguised alien ship. This revelation has generated both excitement and apprehension within the scientific community, as we strive to understand its origin and purpose. The breaking discovery. The initial detection of 3Y Atlas occurred in early 2025 by the Atlas Survey System, an automated telescope array designed to spot near-Earth and interstellar objects. Astronomers were immediately intrigued by the object's extraordinary velocity and hyperbolic trajectory that clearly indicated it was not gravitationally bound to our solar system. Dr. Larry Deneau, lead scientist for the ATLAS project, confirmed the object's unique path and immediately alerted observatories worldwide to begin tracking this unprecedented visitor. The breaking revelation that 3I Atlas was significantly larger and faster than previous interstellar objects reignited debates about the prevalence of such cosmic travelers. The discovery highlighted the increasing sensitivity of modern astronomical detection tools and emphasized the critical importance of global coordination in tracking these extraordinarily rare cosmic interlopers. Initial observations revealed unusual characteristics that defied conventional explanations for natural interstellar objects. The object's behavior patterns suggested it might possess properties unlike anything previously encountered in our solar system. This discovery marked a pivotal moment in interstellar object research, forcing scientists to reconsider fundamental assumptions about what travels through the void between stars. The discovery story. Following the initial detection, astronomers rapidly organized international efforts to gather comprehensive observational data on 3Y Atlas during its brief passage through our solar system. Utilizing powerful instruments including the Hubble Space Telescope and sophisticated ground-based observatories, they systematically confirmed the object's size, composition, and increasingly unusual behavioral characteristics. The European Southern Observatory contributed crucial spectral data revealing complex surface features that appeared inconsistent with known cometary or asteroidal bodies. Dr. Michelle Bannister from the University of Canterbury discussed the significant challenges involved in imaging such a fast-moving, distant object while maintaining the precision required for detailed analysis. The collaborative international effort underscored both the urgency and scientific significance of capturing comprehensive models of 3I Atlas during its fleeting passage through our cosmic neighborhood. Teams worked around the clock to coordinate observations across multiple time zones and hemispheres. The unprecedented level of cooperation demonstrated the scientific community's recognition that this visitor represented something truly extraordinary. Each new observation added pieces to a puzzle that seemed to defy conventional understanding of interstellar objects and their expected properties.
A stranger in our midst.
3I Atlas exhibits characteristics unlike any object previously observed in our solar system or beyond. Recent measurements indicate it possesses unusually high reflectivity and metallic surface characteristics that fundamentally defy typical comet or asteroid classifications used by astronomers. Dr. Alan Fitzsimmons from Queen's University Belfast analyzed extensive telescope data, highlighting the strange spectral signatures indicative of advanced materials, rather than natural rocky or icy compositions. Traveling at nearly 60 kilometers per second, the object exhibits unexpected trajectory modifications that some researchers interpret as evidence of artificial propulsion systems. These remarkable anomalies have led a growing number of scientists to propose that 3Y Atlas may represent a technological artifact, possibly an extraterrestrial probe deliberately sent to observe our planetary system. Continued observations aim to definitively determine whether its behaviors represent unknown natural phenomena or constitute evidence of intelligent design and construction. The object's surface appears remarkably smooth and uniform, lacking the typical irregular features expected from natural cosmic debris. Its thermal emissions follow patterns that suggest internal heat sources rather than simple solar heating. These discoveries have fundamentally challenged existing models of what interstellar objects should look like and how they should behave.
The predecessors.
The previous two confirmed interstellar visitors, known as 1I/Oumuamua discovered back in 2017 and 2I/Borisov detected in 2019, provide crucial context for understanding 3I/Atlas. Yet, none of these objects actually share its peculiar characteristics. Oumuamua, for instance, initially baffled scientists with its really unusual cigar-like shape and that completely unexplained non-gravitational acceleration, which honestly just defied conventional physics. In stark contrast, 2I/Borisov displayed classic cometary behavior, showing typical outgassing patterns and developing a visible tail, just as you'd expect from natural objects. 3I/Atlas, though, with its massive size and highly reflective surface properties, fundamentally challenges the notion that interstellar objects always conform to previously known natural archetypes. The growing dataset from these three dramatically different visitors is systematically reshaping our understanding of what might actually be actively traversing our galaxy. Each visitor has contributed unique insights while, at the same time, raising increasingly complex questions about the diversity of objects traveling between star systems. The progression from Oumuamua's mysteries to 3I/Atlas's apparent technological signatures really suggests an escalating complexity that, well, demands serious reconsideration of our assumptions about interstellar space and its contents. The Cosmic Journey. The cosmic journey undertaken by 3I/Atlas spans potentially billions of years, originating from some unknown star system located far beyond the boundaries of our solar neighborhood. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory explains that the object's estimated age and remarkable velocity suggest it has successfully survived countless cosmic events, stellar encounters, and gravitational interactions during its extended voyage. Its calculated trajectory indicates a passage through the harsh environment of interstellar space for, wow, potentially over 1 billion years, making it an ancient relic from the early epochs of galactic formation. Sophisticated spacecraft instruments have detected faint emissions, possibly linked to its primordial origin, which offers researchers a unique observational window into materials and processes from beyond our solar system. Understanding this extraordinary journey provides crucial insights into the fundamental processes shaping galactic evolution and the distribution of matter throughout cosmic history. The object's apparent structural integrity after such an immense voyage raises some pretty profound questions about its composition and construction. Natural objects typically show significant degradation after extended exposure to cosmic radiation and micrometeorite bombardment, yet 3I/Atlas appears honestly remarkably well preserved. A scientific goldmine. The discovery of 3I/Atlas represents without a doubt an unprecedented scientific opportunity, with an international array of telescopes and observatories now focused on capturing every possible detail during its passage. Scientific teams from NASA, ESA, and numerous other agencies are collaborating intensively to analyze spectral data, refine orbital models, and systematically search for evidence of non-natural phenomena. Dr. Sarah Seeger from the Massachusetts Institute of Technology emphasizes the extraordinary opportunities this visitor presents for studying interstellar chemistry, exotic materials, and potential technological signatures. The comprehensive data collection effort could, potentially unlock fundamental secrets about planetary formation processes in distant star systems and provide insights into the prevalence of advanced technology beyond our solar system. Each observation is carefully coordinated and scheduled to maximize scientific return during the object's limited time within optimal viewing range. The international cooperation on this project demonstrates unprecedented levels of coordination among research institutions that are typically quite competitive. Advanced imaging techniques are revealing surface details that really challenge our conventional understanding of natural space objects. Spectroscopic analysis has detected unusual emission lines that don't match any known natural materials, fueling speculation about artificial construction and exotic engineering materials. Unanswered questions. Despite extensive international study efforts, fundamental questions about 3I/Atlas remain frustratingly unanswered, leaving scientists divided about its true nature. Dr. Avi Loeb of Harvard University points out that certain observed behaviors definitely defy all known natural processes, including, unexplained acceleration patterns and highly unusual surface reflectivity characteristics. The object's true internal composition, structural configuration, and ultimate origin remain completely elusive despite intensive investigation. Competing hypotheses range from exotic natural cometary remnants to sophisticated artificial probes, potentially sent by extraterrestrial intelligence for reconnaissance purposes. Ongoing research efforts focus intensively on resolving these mounting mysteries, bolstered by significant advances in instrumentation and increasingly sophisticated observational techniques. The international scientific community remains fundamentally divided, carefully balancing healthy skepticism with genuinely open-minded inquiry as new data continues emerging. Some researchers argue for natural explanations involving unknown physics or exotic materials, while others increasingly favor artificial origin theories. The lack of definitive answers has created intense debates within astronomy journals and conferences. Each new observation seems to deepen rather than resolve the central mystery surrounding this enigmatic visitor from interstellar space.
The alien question.
The possibility that 3I/Atlas represents alien technology has moved from fringe speculation to serious scientific consideration among mainstream researchers studying its anomalous properties. Evidence supporting artificial origin theories includes the object's unusual mathematical heat emission patterns, sophisticated trajectory adjustments, and surface materials that appear inconsistent with natural formation processes. Dr. Seth Shostak from the SETI Institute reports that thermal emissions follow prime number sequences that are extremely unlikely to arise naturally and may represent deliberate signals or encoded information. This finding significantly strengthens the possibility that the object functions as part of a broader network of interstellar probes, communicating through universal mathematical codes that any technological civilization would recognize. The hypothesis suggests systematic interstellar exploration conducted by advanced civilizations using sophisticated reconnaissance technology designed to remain undetected until closely observed. Understanding these potential signals could fundamentally transform our approach to searching for extraterrestrial intelligence and establish first contact protocols. The implications extend far beyond academic interest, potentially representing humanity's first confirmed encounter with technology from another world. Such a discovery would necessitate careful consideration of response protocols and international cooperation in managing potential contact scenarios. Observing the visitor. The global astronomical community has mobilized unprecedented resources to observe 3I/Atlas, coordinating space-based telescopes, ground observatories, and advanced detection systems worldwide. Dr. Nancy Grace Roman's Space Telescope operations have been specially configured to track the object's trajectory and capture high-resolution images during optimal viewing windows. The Vera Rubin Observatory contributes continuous monitoring capabilities, while radio telescope arrays search for potential technological emissions or communication signals. Dr. Michelle Bannister from the University of Canterbury coordinates international observation schedules to ensure maximum coverage as the object traverses different regions of sky visibility. Advanced spectroscopic analysis reveals surface features that appear artificially smooth and uniform, lacking the typical irregularities expected from natural cosmic debris shaped by millions of years of space weathering. Thermal imaging detects internal heat sources that suggest active systems rather than passive solar heating patterns typical of natural objects. The coordination represents the largest international scientific collaboration in astronomical history, with researchers sharing data in real time across continents. Each observation window provides crucial data that may determine whether humanity faces a natural phenomenon or evidence of extraterrestrial technology visiting our solar system.
Dawn of a new era.
The implications of 3I/Atlas extend far beyond simple astronomical curiosity, potentially marking the dawn of a new era in humanity's understanding of our cosmic environment. Dr. Michio Kaku from City College of New York suggests that whether this object proves natural or artificial, it fundamentally challenges our assumptions about life, intelligence, and technology in the universe. The systematic study of 3I/Atlas has already driven innovations in observational technology, international cooperation protocols, and theoretical frameworks for understanding interstellar phenomena. These technological and methodological advances position humanity to better detect, analyze, and potentially interact with future cosmic visitors. The growing frequency of interstellar object detections suggests we may be entering an era of regular contact with materials and possibly intelligence from beyond our solar system. Future missions may attempt direct rendezvous with similar objects to conduct detailed analysis impossible from Earth-based observations. The scientific community recognizes that 3I/Atlas represents either an extraordinary natural phenomenon or humanity's first confirmed encounter with extraterrestrial technology. Either conclusion would fundamentally alter our understanding of our place in the cosmos and our readiness to engage with a potentially populated galaxy. The ongoing study of 3I/Atlas continues to challenge everything we thought we knew about interstellar visitors and our place in the cosmic community. Whether this mysterious object represents advanced alien technology or an exotic natural phenomenon, its discovery has already transformed our approach to studying the universe around us. As observations continue and data accumulates, humanity stands at the threshold of potentially world-changing revelations. Stay with Stellar Tech for continued coverage of this developing story that may forever change our understanding of life beyond Earth.